Everyone must be aware of my background, so I will be moving because you already have shared my background to this forum. In today's session, a lot of disturbance resounds. Maybe ask someone to mute this in case. So it looks better. Perfect. Yes, today's topic is low latency trading systems, and these are following topics I will be covering. What is low latency trading systems? Why low latency trading systems? Measurement of trading system latency. Why it mostly contains wire time latency, network processing latency, operating system latency consideration, application processing latency consideration, and then I will talk a little bit about direct market access in low latency trading. That's one of the things like mostly being used across, if you can say, proprietary trading or systematic trading desk. Uh, Without talking about FPGA in high frequency trading, things will be incomplete. So I thought probably to add it. InfiniBand is another key discussing point. So I thought probably some element of InfiniBand where I try to add and give the flavor of low latency trading systems. And in the end, like I will talk about the recent trend about the low latency trading systems. So going further, right, low latency trading system, right, is it's a combination of many things, right? It's not only just an applications development. It also includes very good understanding about hardware and operating systems, also understanding about network devices, networking concept. So these are mix of all these four, right? What exactly, why low latency technologies turn out to be unique in itself. And I can say with the advent of algorithmic trading, the need for low latency trading platforms become very crucial. And in this market data exchange environment, especially in electronic trading, where, for example, when executing arbitrage strategy, every millisecond lost may result in 100 million lost opportunity. So speed becomes the key differentiator, making it critical to establish the lowest possible latency between processing component uh, in the environment. So the ultimate competitive advantage in business that supports low latency trading lies in the ability to access the liquidity pool faster than the competition, outperforming competitors during peak periods of intense activity. So these are something like we have to use this low latencies, that is the possibility. So it requires a lot of agile, high performing infrastructure that address the enormous volume, especially during the massive burst and the surge of high rate of data speeds, which are typically associated with a period of market volatility. So those periods, we have to be careful with our systems, and this whole consideration about the low latency systems play very critical roles. So here I try to put like how exactly traditional trading system look about, and you can say market data gateways like exchange, and we have market data handlers, that is, can say feed handler. The mostly feed handler take care of network related processing for communication with exchange market data gateway. Others like security-based filtering consolidations also take care of message parsing is another key thing that it does, and then pass the message to order books. And order books build and maintain full order books, or customizable depth order book delivery, maintain the security-related trade statistics, and then pass it to rule processor. Rule processor, it maintains the information related to trading strategy as provided by some rules, business rules or cancer strategies, which will be on a real-time basis. It also instructs the risk management systems, like how to place the orders. It's just like I think it asks make a request for order placement. So risk management systems, it ensures the risk compliance for the order placed to the exchange and then pass it to order handler. Order handler, it take care of lot of TCP related processing for interactive communication with exchange order gateway. You can see this. So order request and order response, like these are things like being take care of that. Sorry, like I forgot to mention about the rule controller. Rule controllers are mostly about this. It's like defining the strategy, right? Like how to monitor, control, as well as build the strategies. So yeah, these are mostly traditional trading system component. Like we take cares, like others could be equities or it could be we can say is FX trading or fixed income trading. So mostly we use for that. So right, like here we have to ask these questions like uh, why low latency trading systems. But getting into that, like I've come with a diagram. Like if you look into these diagrams, like we have the algorithmic tradings, like there's definitely uh, multiple way you can do. Anyone can do the trading, and one of them is like algorithmic trading. Other is like manual trading, or someone can say mix or hybrid trading as well. So probably in my last of the session, I covered like this what exactly is high frequency trading, and I try to talk about the algorithm trading and different strategies, right, like that. So probably quickly I will go through that. Here itself, algorithmic trading is the process of using computer program to follow a defined set of instructions for placing or trade in order to generate profit at a speed and frequency that is impossible for human trader. And high frequency trading is a subset of algorithmic trading. So it involves placing you can say thousand orders at very fast speed. The goal is to make tiny profit of each trade, often by capitalizing on price discrepancy for the same stock or asset in different markets. So this is like mostly we do in high frequency trading. We also talk about statistical arbitrage, which comprise a set of quantitatively driven algorithmic trading strategy, and these strategies look to exploit the relative price movement across thousands of financial instruments by analyzing the price patterns and the price differences between different financial instruments. Also, there are market making strategies that let any trader make money when executed with relatively or stable instrument. So market maker earn their profit by providing liquidity for other traders. They do so by creating limit order in both direction, and they take the bid ask spread as their earned income. So idea is very simple: buy low, sell high. So you can do in either of the directions, right? So low latency strategy. It's all about trading. Low latency trading is to execute trade without manual intervention at the fraction of few microsecond or at the zero latency itself, or you can say nanosecond. Now people are talking about nanosecond. So any high performance trading system would need two component majorly: a high throughput system to process millions of messages per second, or the low latency systems with a response time of microsecond or nanosecond. Here I try to use this diagram. You can see like a lot of activities, right? It's going on for picking the market data, like a lot of decoding, normalizations, analytics, caching, strategy buildings. Like a lot of activities are there. Definitely, I don't want to get into details at the moment. So just look into that. This what exactly what exactly latency, right? Like what exactly we understand about the trading system latency. So whenever talk about latency or message response latency, that can be defined as a duration between the submission of a business message, like order entry, amendment, or cancellation, and reception of the system response to the business message through either initial acknowledgement or initial execution report. So that like it's like measuring the time difference between two different data point, where execution is started or where execution completed, or like you can say otherwise we can measure. So if you look into that, right, like there are four major factors like which combine together. I already mentioned about that. Low latency systems, which is the wire time latency, network processing latency, operating system latency, and application processing latency. These are major component which contribute toward the latency, and our purpose, our effort, like to cut down the time, the delay itself, as minimize as much possible. So idea is like earlier we were talking about millisecond, now we cross this microsecond barriers, and now we are thinking to the next level of nanosecond, almost like zero latency is barrier. So these are our effort to keep on going, and like we have to take care. I mean to say it's like different factors which contribute any kind of latency. So understanding about these different factors like very important for, yeah, if you're going to work for the low latency trading system or ultra low latency trading system. So my next four slides mostly it will be talking about these four factors. So here I'm talking about wire time latencies, right? Like what exactly wire time latencies? It's all about like how much time we spend whenever any message which has been passed, maybe, sorry, whenever we talk about like live market data feed, like we have a chain gateway, it reads the data from the chain gateway, and it has to cross some kind of distance. Like if we have the trading systems sitting in Hong Kong or located in Singapore, and it has to do the trading with you can say New York stock exchanges. So there must be a way, like we have to connect with New York stock exchanges and make a request for specific securities data, real time data. So right, like wire time latency demand, right, like whenever traveling from this different location, from one location to another location, why the mediums like it covers, right? Like so earlier we were using copper metal wire, definitely like how we electronically we or we this any message has to travel, then we come across this fiber optics, and then like we are also talking about microwave uh, fixed length or fixed messages microwaves. That's another technology we are talking these days. So fiber delay, it's all about talking about like how uh, what the length of the actual fiber, where exactly the fibers, and from where this message has been sent. It's like the physical route it covers. The greater the time it takes for traffic to get from one end to another end, it's like latency will be higher. So right, like it's like yeah, this is all about this fiber delay. Like it's all about like physically how much time is spent traversing for one message, right? Like within this of fiber optics. So I can give, right, like message processing latency across fiber is largely a function of the speed of light, which is we can say 3 to the power 3 multiplied by 10 to power 8 meter per second in a scientifically controlled environment. Like mostly we say equal to this whenever we do this computations, like it is almost like 3 microsecond for every kilometers, like it will require the time it will going to elapse whenever we any message has to traverse physically in this wire itself. So when measuring latency of data, we need to account for the fiber optic cables. For measuring latency in long haul network, the calculated latency is actually 4.9 microsecond for every kilometer. So right, like we generally say it's a kind of two-third of speed of light, right? Like this is like a measurement we generally use for computation. There's another one is a proximity delay. This amount the space near the fiber access point is a finite quantities and the firm that can locate its equipment closer to fiber access point. Whoever closer to fiber access point will have the competitive advantage. And we talk about co-located servers, right? Like which is very close to any exchange. Mostly when we talk about co-located servers. There's another delays which is which cause a delay this within this wire time latencies, equipment delay, and uh, what everyone believes, the data I already mentioned, like the data in a glass network of fiber optics actually moved at the speed of the light, and every devices introduce some amount of delay, and therefore any non-optimized transport equipment across the information patch can thwart business model that are based on the most challenging network latency limit. So eliminating this source of equipment delay is a bit trickier because different devices carry out key common optical network functions in very different ways. Like I mentioned about like different optical network function. Every devices deal differently. This is very specific to device, and they are mostly color conversion, amplifications, dispersion compensation, and regeneration. These are common optical networking functions that are carried out among different optical networking solutions, and like any enterprise that fail to understand how its wavelength division multiplexing, well, mostly known as WDM gear, it's like a WDM gear which accomplishes these four basic functions, definitely risk put into a risk like how much time it takes for networking instruction to be executed after being issued. So it's very very important to understand these four functions, and these are also always cause some kind of latencies, and unless until we know these functions, definitely in a latency sensitive algorithmic trading a firm whole business strategy could be jeopardized by ill-fitting implementation of necessary optical transport function across the different fiber networks, which is linking the key location. So it may cause us multiple yeah, latencies. I don't have to tell any kind of unit into that, but we have to be very careful to take care of that. So these four optical networking function, which is mostly termed as the equipment delays, we have to be very careful into that. So yeah, understanding of network device is very very important, key aspect of that as well. Uh, yeah. Next is networking processing delay. That is mostly the time delay it takes router to process the packet header. So networking processing delay is the main component of networking network latency. Uh, I don't want to get into very deep into that. It's going to take a lot of time. So yes, any networking processing delays, we compute by four of this component I mentioned here. One of them is propagation delay, transmission delay, queuing delay, and processing delays. So these delays, like how exactly it works in this any networking traversing of the messages within the wire, and like we have to know about this, and this also key proponent for any kind of networking latency. So here I mentioned a few of these things, like Ethernet switches, how much time is going to take, 10 Gbps Ethernet switches, 10 nanosecond. This is the latest, right? Like now we are using almost 40 Gbps to 100 Gbps. So we are also cutting down this latency. If you use a simple core internet router, it mostly takes 50 microsecond latencies. Trading latency is almost like 85 microsecond. Metro area network 20 millisecond. WAN area network 75 millisecond. These are some old data, but yes, like we need to understand how this different network, uh, this any messages using this yeah, or you can say different component we are using for network processing. So just like this is more of like average or mean values, uh, but these are something like we nowadays we are using mostly Ethernet switches, very ultra low latency Ethernet switches are mostly used in high end systems, or you can say low latency trading systems. Next is uh, there are a few things I forgot to mention about that. Like I think it's better to understand the terminology that is mentioned about that latency jitter, like packet transmitted continuously on the network will have different delays. Like uh, I mean to say, any specific time there is no continuity or consistency in terms of the delay. So sometimes it choose the same path, delay is still different. So it happens like in a packet switch network for two key regions. Like firstly, packets are routed individually. Second, network device receive packet in a queue. So constant delay cannot be guaranteed. So we term it as a latency jitter. These are terminology probably you have to understand that. And these delay in consistency between each packet, which is known as jitter, right? Like and it can cause this issue for real-time communication. So what exactly this jitter can cause? One of them is packet loss, second is network congestion, and these are something like really create the problems. Like whenever we have network congestion, there will be more packet draws, and like uh, there will be some issues like delays, and the system may cause the problems in terms of uh, sending the message from one end to another end. So right, like we need to know what exactly jitters, and there are ways like we can come across or we can try to deal with that. That is like or how can we compensate the net network jitter? That is we can have like different jitter buffer, like static jitter buffer, dynamic jitter buffer. So these are something like maybe if you know this terminology, right, like you can do further Google and check into that. And there are another thing, right, throughput, like probably in a low latency trading systems, throughput is another terminology we need to understand. And throughput can be defined as the amount of data processed per unit of time. Throughput refer to the number of messages being received, sent, and processed by the system, and usually measured in update per second. So throughput has a correlation to latency measurement, and typically as the message rate increases, so do the latency also increases. So throughput and message latencies are some correlations, so we should be aware of that, right? Like what exactly throughput and yeah. So these are terminology. Probably any guys who want to know about this low latency system should be aware of that. Okay. Next is like operating systems, right? Like whenever wires message traverse through this wires, crosses different switches and come to this our system, operating systems, like where our servers and application are up and running, right? Like so there are a few considerations we need to take care of that. The one is this minimize propagation delay by using high-end co-located server, which I already have talked about that. Minimize the queuing delay, like something like TCP's window sizing and other factors, buffer, something we have to take care of that. uh, Transport layer implementation, like what are the best ways the transport layer we need to take care of that, either TCP, UDP, or IP multicast, like those are consideration we need to take care of that. Best uses of middleware techniques, like Apache Kafka, Zero MQ. In my last jobs, I was using Nano Message Bus. So these are some of these latest middleware techniques. Probably we can uh, try the best. We also need to have good understanding about the application, different communication channel, one to one, one to many, point to point. Yeah, like some event, let's say CEP, complex event processing. So all these things, like we should be aware of that. Like that definitely will help uh, to finding this the best how we can design like our system. Good knowledge about high-end server and operating system. So the kind of multi-core CPU, uh, different Linux systems, or maybe Solid system, what exactly the operating systems specifications, we need to aware of that. And moreover important is security and compliance guidelines. Right, like this is all about like whenever we decide what kind of hardware we are going to use it. Like mostly, if you look into there's a trend and everything, right? Like most of the time, people are using Linux server, and Linux servers are has been used since quite long time. It's not like Windows system or Windows servers are so bad in terms of number, but yes, like so far, Linux systems has outperformed most of servers. So yes, like you can find a variant of Linux servers which has been used for low latency systems. And whenever we go, right, like we have to be very careful. Uh, the performance tuning, that's a very important aspect of our hardware configuration. And if you look into that, right, like uh, there are low latency bus tuning, right? Like mostly different Linux systems provide what exactly a configuration will be well suited for low latency system. So we need to follow those guidelines. And there's another thing like a PCI locality, right? Like peripheral component interconnect is a computer bus for attaching hardware devices in a computer. So it's the acronym for, yes, I already mentioned peripheral component interconnect, and it's provide the local bus standard. So support the function found in a processor bus, but in a standardized format. So it is independent of any particular processor native bus, and devices connected to the PCI bus appear to be a bus master to be connected directly to its own bus and are assigned addresses in the processor address spaces. So it's a more like how we going to arrange this like a PCI locality, the parallel bus, synchronous or single bus clock. So there are a lot of things like we need to take care of that. So yes, like I really don't know it. Like I never tried in my life. So any guys who are very good hand in hardware configuration can help into that. There's another thing like NUMA topology, right? Like non-uniform memory access. I believe like many guys in low latency trading systems is using right like this non-uniform memory access, and it's all about increasing processor speed without increasing the load on the processor bus. So sometimes like the architectures like keep this memory bus or like memory access non-uniform because each processor is close to some part of the memory and further from other part of memory. So processors should have access to the memory which is close to. This is all about NUMA topology talks about, and it's mostly computer memory design used in multi-processing, where the memory access time depend on the memory location relative to the processor. So this is something like nowadays people are talking about NUMA topologies, and many trading systems started this kind of I mean to say is this kind of standard to get the benefit of this topology. So yes, like definitely I'm not the best guy to help you into that, but yes, like go and check for more into that. And yes, share me this information about that. But yes, whatever I know, right, in NUMA system, CPU are arranged in a smaller system called nodes, and each node has its own processor and memory, and it is connected to the larger system through a catch coherent interconnect bus. So that's how we try to play around with this what memory is closer to a specific node, and we try to direct or some kind of tables we try to uh, convey, right, and memory access will be closer, and it's it's help like getting the benefit of uh, yeah, this you can say is uh, we can have access to local memory faster, and it helps with the latency number. Using the network latency turn profile, that is also very specific to systems. And if I look into the Red Hat Enterprise 6, 7 have their own network latency profile definition, and that is meant for high throughput custom profile like feed handler, gateway, matching engine. So everyone having its own, you can say, profiles, and maybe we can tune up accordingly. So there's another interesting things like low latency kernel bypass or zero copy networking techniques, and it helps like a kernel bypass. I think Solar, Flare, open on load techniques are mostly used nowadays in many I think the most of low latency trading systems. And another is kernel zero copying network technique maybe. And if some of the slides I will talk about later. And this is the application processing latency consideration. This is mostly whenever you build your uh, feed and write about order management system, risk profiling, and all. These are some of the best consideration. You can try it out. Choose the right language. Keep it all in memories. So right languages like C, C++, Java, Scala. All these are being used for building the low latency systems. C++ is mostly being used, and Javas are very close to that. But yes, like you pick your right language accordingly. There's no hard and fast rule, right? But definitely you should not try it out Python. Python is an interpreted language and very slow in terms of performance. Next, keep it all in memory. So system level input output will kill your latencies. So make sure all your data is in memory. This generally means managing your in-memory data structure and maintaining a persistent flow so that you can rebuild the state after a machine or process restart. So it's a good idea to keep it all in memory, keep data and processing co-located. So it just like cut down the network hops. Network hops are faster than uh, disk seeks or are looking for disk memories. But yes, make this co-located. It's cut down a lot of overhead, and we try uh, uh, try to fit this your data entirely in memory at on one host, something like that. But yes, there are no hard and fast rule. You have to look into your system. You have to design and find the best things for yourself. uh, Keep the system underutilized. Low latency requires always having resources to process a request. So yes, don't try to run at the limit of what your hardware software can provide. So if you cross the limit, definitely it will yes it may impact your the system performance. Keep context switch to a minimum. This is something very important. We while kernel bypass or kernel zero copies are becoming very popular nowadays. To avoid the context switching like is a sign like you are doing more compute work than like you have resource for. So yes, it's like thread level context switching, or maybe system level context switching, whenever come across with the kernels or thread, It cut down this like it's a hamper the performance system performing. So the best is like you have to limit your number of thread to the number of cores in the on your system, and maybe try to bind each thread to its own core. Maybe that's another way like we can avoid context switches. There's another thing like keep your read sequential, like all form of storage, whether it be rotational, flash based, or memory, perform significantly better when used sequentially. So when issuing sequential read to memory, you trigger the use of prefetching at the RAM level as well as the CPU cache level. If done properly, the next piece of data you need will always be in the L1 cache. I believe, right, like know about L1 cache, L2 cache, and L3 cache. So if the any read sequentially is always better and easier and faster. So yeah, just follow this rule. Batch your writes. One thread should spin in a tight loop doing system IO calls. Each write will batch all the data that arrives in the last write was issued. So this makes for a very fast and adaptive shift system. This is like experiences. Respect your cache memory access quickly becomes a bottleneck, right? Like pinning thread to their own cores, helping reduce CPU cache pollution and sequential IO also helps preload the cache. So just like try to use your cache judiciously. That's what like everyone advise for that. Non-blocking as much as possible. Uh, anyone's using it like synchronizations. Avoid as synchronizations as much possible. That's the key thing. Maybe right like we were using a lot of ring buffers or disruptors techniques, right, like to avoid synchronization mechanisms. I've tried few of this system implementation. Asynchronous calls, right? Like I think everyone aware of that. Try to make asynchronous call as possible, and maybe you link with or pin with any specific thread or core, right? Parallelize parallelizations as much as possible. Any processing, any particularly any input output call that can happen in parallel should be done in parallel. So as simple. Yeah, these are something like we should try like the best practices I can say. Optimize the packet size, minimize the packet size or message payload, right? Like prefer as message payload as minimum possible. Like it helps data processing itself, data encoding, decoding, all this helps. Try use this base data structure algorithm, mostly order of one complexity. This is what like we should try using Saturn map, maybe on our Saturn on our map, either going to be C, C++, Java, or any other languages. We already talked about minimizing the network hop, uh, invest in messaging middleware techniques. Yeah, we already talked about that. IP multicast, TCP, and UDP protocol. We have to use as on a need basis, right? Like mostly we should go for IP multicast whenever we are talking about IP message feed handler, client connectivities. We should go with the UDP protocols by default, and if we show like it has to be uh, we can say is that the reliability whenever reliability data has to go from one end to another end, like then only go for TCP protocols. So these are something like yes, best practices you can try and follow for building this ultra low latency system.
Great, Varun. Varun, actually, few of the guys have put some questions on chat. So,
Yeah.
like before moving to the next slide, can you take those questions?
Yes, surely. Can't
Okay.
see this question. Where exactly is this question? Let me see the chat here. Yes, right. Like definitely solid state. Yeah, RAM or something like we need to take care of that. Uh, just like whenever we are going to store the data, right? Like, and whenever we are talking about caching, then only we have to look for RAM available RAMs and now like as much like RAMs available, it helps to the system. Solid state disk, right? Like definitely helps in terms of data fetching or responsiveness on that, but we whenever we talk about low latency system, right, like probably solid state uh, disk may not be very helpful because we try to put everything into cache, and that's how we work. But yes, like if you try to make it more responsive call, and we have a lot of data interactions with data sets, right, like going to be maybe Oracle's database or maybe MySQL. We whenever we talk about low latency trading system, we avoid directly interactions with that unless until we have some asynchronous call, and then only we try to interact. Otherwise, uh, we don't want like to cause any kind of latency because of that. But yes, like these are something we have to take care of that. I agree with that. And L1, L2, L3 cache for pneumo topology. Yes, like definitely. I mentioned about that. I'm not the best guy to talk about that. Maybe sometime later. It's requires deep diving and understanding on that. Like I never did on that. So yeah, I have to get. If you have very specific question on the topology on L1, L2, L3, definitely I will take and will try to get into that. Otherwise, we will need another session into that. That's what I can say. All right. There are two questions only, right? Any other question?
I think that's it. Like you can move on to the next slide.
All right, right. Like I think I've covered the most of these four important components which causes latencies, and like if we take care of these four components, and we are good to build very ultra low latency systems. Yes, but it's it is like forever race. It's like arm race. Like you always find like someone is trying to beat you, and you always have to be on top of that. So it's like a competitions, forever competitions, and like I will talk about the trends, how trends are going forward, and you can look into that. But yes, like why these fields are very very challenging because you always have to come up with a nice, better solution from your competitors, and so you have to beat your competitor, and we have reached to the level to where like beating other computer it won't be, it really needs a lot of research work, right, like and you have to have complete understanding about systems, processes, uh, I mean to say is networking devices. So many things are we have to take care of that, and like many guys are doing that, but it's a very challenging and like interesting topics to be part of. There's another thing like very we can say next this slide about direct market access in low latency trading. If you have any other question, right, like from the last four component, because most mostly latency, right, we are only talking about these four components. Rest of other slides are all about this, what exactly how we're using the latencies in to get the benefit of, right, like how we try to build this low latency system using some unique ways. So these are all about. If you have any specific question, like I can wait and I can take the question. If not, definitely I would like to proceed. Low latency is direct market access. It's another set of technology used in a modern trading strategy where speed of execution is very, very critical. Direct market access, often combined with algorithmic trading, is a means of executing trading flow on a selected trading venue by bypassing that broker's uh, traditional method, right? So it's all about, we have to trade into MX exchange or maybe Nike exchange, and whenever clients send order directly to the market, like it's like without informing brokers or without doing any kind of risk, right, like a lot of risk management we have to take care automatically, right, like a lot of things we have to take care of that. But here, instead of involving any third party or any kind of considerations, we put the rules and we send the order directly to the market without any like intermediary systems or something like that. So this is all about direct market access. If you know, like all rules are well set, well fit, and we directly send the orders directly to the market. So this is all about direct market access. And uh, yes, we have been using direct market access and made a lot of money out of that, right? Especially dark pools and some institutional high frequency, like high volumes tradings that helps making a lot of money using direct market access. So, right, yes, as I mentioned, DMA, direct market access, is a process by which traders transmit order on their own without any handling or re-entry by another person. Like straight, it's less like another straight through processing. And yes, because there's no intervention in between, it also termed as a no-touch execution. And just like a DMA, direct market access flow passes directly through DMA gateway and onto the venue we are already established. We already know how exactly it will be passing through, and definitely there will be risk checking and position keeping algorithms we have to put into place. So risk and position management we have to ensure before sending the order directly to this direct market access. So faster the speed than your competitor, better your chance of winning. This is the main objectives here. So yes, rewards are very high if things goes well. So right, I uh, so here few of the things I have put into that. This after advent of direct market access, definitely it helps because there are no intervention, no touch order executions, right? It reduce micro to millisecond sometimes, yeah, it order management has to be, yes, like because sometimes we send thousand of orders in a second or maybe more than that. Sometimes I've seen people are using more than 1,000 messages per second executions, and we have to ensure like all compliance, everything are well in place, and risk management has to play right like a major role into that. So yes, there are chances people can use wrong ways and all, mostly you can say very strict compliance rules are placed. This is what like every proprietary trading or any kind of trading desk has to take care of that. So just like benefit of direct market access, latency reductions, minimal slippage. I believe you guys know about slippage, right? So slippage is all about right now we execute this trades, and whenever this real trade execution happens in the market, it's a different trade, right? the difference between what the trade you have executed and what exactly trade had been executed in the price difference is termed as a slippage. Sometimes it also cause a loss. So yes, we have to minimize the slippage because of the time gaps are very minimal. Anonymity, like I mentioned about the dark pools trading, many big or institutional banks are using and DMA matches the order of trader to liquidity provided without first passing through brokerage servers. So right, like anonymity is something like that also gives price improvement, like any traditional market settings, traders are quoted the best available price in which they have to buy or sell a financial instrument. But under the DMA framework, participants are able to act as a market maker with the option of submitting order before ever accepting a quote. So that also is another thing, like can help with the better trading strategies. Um, there are benefit. There are also some of them are drawbacks. I did not put into that, but yes, like data lag, platform compatibility, account size, trader complacencies. So these are something like uh, it also turn out to be a big disadvantage of using DMA. All right. So next, like I'm talking about FPGA, right? Like it's any question like regarding this DMA's? Any questions so far? All right, like if there's no question, like quickly move into FPGA, like term as a field programmable gate array, and it is playing a major role nowadays, like especially in high frequency trading. It involves low latencies as they compute in parallel using logic gate instead of running sequential code in software. So I believe you guys are aware of CPUs, GPUs, like how it works. And CPUs mostly is a multi-core servers we have, and they use some kind of CPU, central process unit. They always work on a sequential, but yes, like using the FPGA, like we can uh, FPGA is like hardware, right? Like that runs in a custom integrated circuit, except that logic can still be reprogrammed on a device which is already deployed in the field. So like it's all about like multiprocessing and like reprogrammables logic gate, right? Like how we get this good latency number. I mean to say very low latency number, and moreover, like it says it's more deterministic than software. What exactly it means? Like whenever we have the message burst, and sometimes like it cause message loss or some kind of other problem with the system. But this is not going to happen with FPGA. So so right, like if you look into this FPGA, nothing than more than a chip containing millions of logic blocks. They repeated throughout the silicon. That's what like say. Each of these logic cells called lookup tables (LUTs) that include basic logical operations such as booleans and or NAND on XOR. And yes, like definitely some of them are parallel architecture determining those are like plus point of using FPGAs, and one of them Algo Logic's gateway that they are claiming that they are able to reduce the latency from 17 microsecond earlier to less than 1 microsecond using FPGA. So it's like a big claim, definitely, uh, and it helps like achieve this the purpose objective what we are trying to. Yeah, that is like zero latencies systems what we are trying to build. So yes, like their hardware implementation, right? Like something we have to play around. So you can look into the figure, right? Like I try to bring into that, like here CMEs change, data are coming, and data have been read by FPGAs, and then it is passed to trading servers, and yes, we can see this I mean to say is positions and trading execution. Trade server take care of that, and some algo logics. So yeah, these are telling like how FPGA works. And mostly FPGAs are used for parsing the incoming data, providing data filtering, decoding, and normalization, carrying out pre-trade volume, price, and collateral checks, monitoring the value and loss scenarios, financial portfolio, and on an ongoing basis. Also used for calculating yield from fixed income investment or equities, or price of securities, their derivatives. Another is generate the outgoing orders. Like if we can look into that, here they have done the all processings, and now they are sending back this to exchange. So yes, uh, they are transmitting them to matching engine. So FPGA card enables low latency as they compute in parallel using logic gates. Latency in a FPGA solution is significantly lower and more deterministic than the software or applications we build. So yes, that's the key things about FPGA, and nowadays many low latency systems have started using FPGA. So maybe you can see some of the hybrid models. You can look into that. I've mentioned about the few of the uh, activities which has been captured by FPGA, but it can't be all activities, but some of them. All right, like another interesting one, like InfiniBand.
Varun,
Yes.
sorry to interrupt. Actually, there is one question, I think. Can you
All right.
elaborate on disadvantage of DMA? So maybe you can take that question before you move on.
All right. Yes, yes, I can try to elaborate data lake. Like data lake is one of the things I mentioned about that. That is you're talking about elaborating the disadvantage of DMA, right? Yes, like data lake is like obscure data lake and network congestions can destroy the integrity of a DMA connections without the trader being aware. So I mean to say is data lag is a factor, right? It can cause this negatively influencing the performance of strategy built for the low latency DMA provide. So right, some of the times we have this. Let's go to back to sorry. Yes, like some of the things I mentioned about that, if we have the data leg into the systems, definitely if you're using DMAs for direct market access, and you are building your rules based on that, definitely it turn out to be fatal to the system, right? So we have to ensure there won't be latency with the data, whatever the data we are getting, up to the orders, up to this whatever we are building this order books, positions, and all is very correct. There's no problem at all. Then only right, if there is any lag because of systems and other problem, yeah, the whole of your strategies and execution may give a negative result, and you can be lost, it can be having big loss of your lifetime as well. uh, Platform compatibilities, transferring data to and from the exchange market without intermediary may encompass, I mean to say, it's incompatibility, right? Because you are directly connecting with market, and there are some kind of incompatibility in terms of operating system, in terms of languages and all. Yes, that definitely will uh, kill your according to your purpose. So right, like before getting into DMA, we have to ensure like we have this all sort of compatibilities, but sometimes it's not in your control because you're trying to connect with the next chain, and sometimes message format change, sometimes their system changes, and you are not aware of that, and like things are going wrong. Like this is what happens sometimes. Sometimes account size, I mentioned about that previously, depending upon the market, brokerage service, and product being traded. Uh, Securing DMA can require a large account size. We have to follow the guidelines, and it changes from the time to time. So maybe DMA might not be suitable for uh, like uh, the traders who's having a small account size, right? Like it always suit to large institutional banks or just like traders, you can say. So account size also matters, and this guideline keep changing, keeps evolving. So that turn out to be like another disadvantage. Like that always we have to be careful with that. So yes, like risk and compliance are definitely have to we have to put into place. There is another thing like traders complacency, right? Like sometimes you are complacent. I know, right? Like it happens everywhere. If you are complacent and you are about to lose many things, and DMA may also give you some enough window if you are complacent and you are gone. It's something like you have to be very careful. Is this okay? Who has asked chef? Yep, perfect. All right. Any question on previous slide on FPGA? No. Just move to InfiniBand then, right? Like that is like definitely very interesting things. Uh, as we also mentioned it, like this is a kind of network communication protocol that offers switch-based fabric or point-to-point bidirectional serial links. That's how this figure is showing, and it's having like different nodes, right? Like it's having bidirectionals as well as like between processor nodes in input output nodes, disk or storage, right? Like every link has exactly one device connected to each end of the link, such as the characteristic controlling the transmission, sending or receiving at each end are well defined and controlled. So this is all about InfiniBand. InfiniBand is designed to enable the most efficient data center implementation. So if you look into that, like it is the performance and of InfiniBand, right? Like one of them is named Melonex. Sorry, like yeah, Mellanox is one of them, right? Like which is using multiple variant of InfiniBand uh, communication protocols. They are something like spent a lot of money into that. Merging with multiple guys who are into building this InfiniBand. So right, like they are keep evolving, and ultra low latency switches mostly. If you look into previous slide, right? Like we mostly people are using ultra low latency switches. Performance of InfiniBand is far like they have shown like much better than ultra low latency switches. So right, like that is another thing. Like people are investing. Uh, just when I was working Trade Switch, right? Trade Switch, we were trying at the point in time. I'm talking about year 2010. Things has been changed, right? Like the performance at that point in time, and now it is like it's far better. And what exactly plus point is, right? Like it offers a better return on investment with higher throughput and CPU efficiency at competitive prices. So definitely that's another interest for every organizations. Like if you are getting better result with low cost, right? Like InfiniBand can be another solution. So Right, like what exactly InfiniBand does, right? Like if you look into that, here traditional interconnect, like when other servers exchanging the data, right? It has to go multiple layers, network interface card, network adapter driver, transport protocol driver, socket and application, and it has to go with multiple layers, like from kernel level to user level stack, and then also yes, like how they copy one into another end. But yes, like what InfiniBand uses remote direct memory access as its method of transferring data from one of the channel to other. So through RDMA is that what exactly they do? They transfer data directly between the application over the network without using any operating system involvement. So it's completely bypass this kernel. So it's a zero copy kernel bypass, you can say. Here we are completely bypassing the NIC drivers, transport protocol driver, socket. Now we are just like dedicated one buffer to another, and within a layer of all kind of communication, it just bypass. So how like they achieve the zero copy? I think in previous slides I was talking about that. Right. So the application on other sides simply read the message directly from the memory, like what exactly here read the memory, read the yes memories and transmit transmit and copy it to the destination end. So right, like this reduce CPU overhead, increase the network ability to move data quickly, and allows application to receive data faster. So while like InfiniBand, like there are a lot of interest in the market, and if you put into that like advantages, high throughput, lower latencies, enhanced scalabilities, higher CPU efficiency, reduce management overhead, and simplicity. Right, like why like it's giving a lot of advantages definitely, and not everything is advantage. There are disadvantages, probably, but yes, like uh, this is like a lot of interest, a lot of research are going on into that. I can say like they are this guy, this organization named Mellanox, right? Like they are putting a lot of effort into that. I believe like a lot of things have improved from year 2010. I myself have seen to year 2018. But yes, like that is something any low latency trading system will look into that buildings, either using ultra low latency switches or go for InfiniBand. Yes, like this is what I can see, right? Like it's a kind of modern trading systems, right? Like low latency trading systems. How I'm trying to put into in this figure. So we have the change, like maybe a change in the cloud or maybe direct access it being received in the ultra low latencies switches, or it could be or it could be uh, yeah, it could be InfiniBand, and we are also using VMA messaging acceleration software. This is another software like termed as a message accelerator, and nowadays modern trading systems they are using. This is also one of the organization I mentioned, Mellanox. They are working building, right. Like it is used for accelerating messaging traffic, and it is been to boost the performance of high frequency trading application. Like it mostly mean like utilizing BSD socket. Whoever worked on this socket programming maybe aware of that. Like it use a library to offload network processing from a server CPU, and traffic is passed directly to the InfiniBand or ultra low latencies switches, or you can say 10 by 40 GB network adapters. Many training systems are using that. So it also uses the bypassing the kernels, IP stack, and minimizing the context switches, buffer copies. So those are things like VMA, like or messaging accelerations. Try to use that through the feed handlers, get the data from a chain, then go to algo engine, then order an execution engine, and then again it goes through switches to back to exchange gateway. So yes, like these are like modern days trading systems, and few of the trends like I would like to mention, like in year 2017, NASDAQ decreases time to disseminate SIP, Security Information Processor, or consolidated market data, right, from 480 microsecond to 50 microsecond, and now like they are almost like using 20 microsecond. So these are like things has been progress like in very quick time. So SIPs, almost all trading firms are actively using that. Trading firms are bound to optimize infrastructure for quicker access to consolidated market data. More forms and algo application are upgraded for single digit microsecond for tick to trade. That's another thing like it's another trend like we are seeing that uh, speed enhancement like FPGA, GPU, server, caching, middleware. These are interests of like how we can improve and help bringing more low latency systems. Like these are area of interest. Like people are putting a lot of effort into that. And then like yes, fixed engine. Like whenever we talk about DMA, we mostly use a fixed engine, and how we can use the market data order using FPGAs, network interface card, simple algos, fixed engine, SOR, smart order routers, risk check. That is, we can use this. I mean, to say we have already solution available using FPGA, so something we can try it out. Uh, there are like ultra low latencies applications, parallelizations, how much parallels application processing we can do using FPGA, ultra low latency switches, GPU, CPU, multi-core CPU. I believe these are the trends. Let's just look into that. I believe I don't know. I don't want to read all these things, but yes, like I will ask Anchal to share this deck to everyone. Yep, I'm almost done. I'm almost finished that. Like this is all about the low latency trading system. There are more things like we can talk. It's like research, right? Like every topics have a lot of research. Like NUMA topology, we have talked kernel bypass, solar flare, open on load. Like people are using these days a lot into kernel bypass. So these are something like something uh, we have come across in last 2 years itself. Maybe there's a lot of research were going on, but last 2 years we have seen a lot of implementation into low latency trading system, and how we have decreased this number like the latency or the number itself. So yeah, this is all I wanted to talk today, and I'm done from my end. Any more questions? Surely feel free ask.
Thank you, Varun, for your time, and it was a really nice session. I think I learned a lot of new jargons about low latency and lot of things about low latency, like from my point of view. Yeah. As of now, like I don't have any question, but if others have any question, like maybe like tomorrow you might have some question. So feel free to like message those questions to us on WhatsApp, and we will try to like respond you back. And also like I will try to devise some mechanism wherein like all the questions which is being asked for the particular training session, we can basically put it somewhere so that everyone can see it. So I will copy all the questions for today, like, and then try to document it somewhere.
Yeah, surely. Perfect answer, right? Like, definitely, like, so there are so many things, like, I have not covered everything. It's going to be another few hour session. Like it will be ongoing. Like because I did not go into application level implementation itself. So like it itself is a, like a big area to talk about that. Like, uh,
Yeah, and I have unmute everyone. Like, if anyone has any feedback or you want to discuss anything, like you can feel free to discuss it now.
all right. Thanks everyone then, and thanks Anshul for thanks Vikram as well for organizing this session. And going forward, I will share the deck. Anshul and Vikram, right? Ensure like this deck will be shared to everyone.
Yeah, yeah, sure, sure.
Perfect. Thank you. Thanks everyone.
Thank you all. Bye bye.
Yeah. Bye.